Good afternoon. I am Daniela Zeffili from ifremer, France. I am a researcher in the Deep Sea Lab in Brest. So just very briefly present my institute. ifremer was created in '84, so 51 years ago. Has three main missions. The first is to know, assess, and enhance ocean resources and their sustainable use, to improve methods for monitoring and protecting marine environments, and foster social and economic development of the maritime world. ifremer is a quite big institute. We have 6 main centers and 20 stations in France and in the French territory everywhere in the world. So Brest is the biggest one, so you can see the number of people working in each institute. And we have our fleet, so we have 7 research vessels and several underwater systems. And the most famous is Nautil, the Samurai, and Victor and Ariane ROV. So ifremer is the French contractor of the authority for exploration of manganese nodule in the Clipperton area, and for exploration for polymetallic sulfide in the Atlantic Ocean. So consider the Clipperton zone. We did 2 cruises, one in 2004, the Nodding Out, and the second one in 2012, the Beyond, both on board the research vessel Atalante. Here we can see the sampling strategy, the biological sampling of everything. And about meiofauna, we use multicolor, and when we use the submarine, we use the tube color. So we change the diameter, so the first was 10 centimeter, the second 5.5, and normally we sieve at 40 micrometer. So here you can see the sampling area. So this is the Nodding Out cruise. So we can see all the sampling that were taken for everything, also for macrofauna. And here you can see the nodule coverage, so to white very, very low, to green very abundant. And here the sampling strategy for the Bionode cruise. So here again you can see the coverage, the nodule coverage, and the different kind of boxcar, multicolor, and other analysis that we made during the cruise. So the history of meiofauna and ifremer is quite recent. Before there were no meiofauna experts at ifremer, so many of the work were made in collaboration with several of you, with Ghent, with Seabed, with Southampton, and almost all studies about the Clipperton area were made in collaboration with the Seabed. And so there is a list of papers already published. So most of the studies were already presented by Danielle yesterday, and Andy also. So I will just show you the main important message of each work for the French claim area. So considering new species, we have 2 new genera and 16 new species described, considering Copepoda and Nematoda, and you can find the publication here. And we are also several new species of Xenophiophores, so we are big foraminifera. There are some in the macrofauna sites and some in meiofauna sites that are under description by Olga Kamenskaya from Russia. A first study that was presented yesterday by Andy was about the fauna that cover nodule. Veliette and collaborator, and Andy was co-author of this paper, study all the organisms attached to the nodule. So considering meiofauna and macrofauna without separating the two components. And they found 73 protozoan and 17 metazoa species. What they observed that there were a higher number of taxa and a higher number of percentual faunal cover in the eastern part, comparing with the western part of the nodular of the sampling area. It is something similar with the presentation of this morning that was observed in the China area. And they also compared different nodule dimensions, so smaller, less than 4 centimeters, between 5 and 10, and up to 15 centimeters. And what they observed that there were an increase of number of taxa with increase of the size of the nodule, But if we look at the percentage of fauna cover, we found the highest value in the intermediate size of the nodule. There were also a very nice work of Milutin about the nematode assemblages. They study nematodes at species level. This is something that I want to recommend. That when we are at species level, we really think different things that when we have the higher taxonomic level. So at least what we can see that all these very nice papers that were published on this subject. So they observed different nematode assemblages comparing the nodule-bearing with the nodule-free samples. The nematode densities was an average 100 individuals for 10 centimeters square. Altogether, they found 325 putative species, and we estimated more than 500 species. Another example that was discussed yesterday and this morning was the experimental dredging that was conducted in 1978. So it was conducted by the Ocean Minerals Company. It was a really, they really simulated, they really take the nodule as a company normally do. It was 1.5 meters, if I remember well, the white, and they take the first 5 centimeters more or less of nodule sediment. And so after 26 years, we came back and we studied the nematode assemblages inside and outside the track. So what we observed was a different community in the dredging track. And if we look at the species level, so we can see the nodule bearing, the sediment, nodule free, nodule bearing, and inside the tracking at species level, at genus level, family level, we can see that species level and the value are still very, very low. So what are the main message of this paper is the total density was it's lower, it's not so lower, but it's still lower after 26 years, but the very main difference is in the community composition and in the value of diversity at species level. So it seems that for the species, for nematode species level, there is a very long recovery period. That seems to be more than several decades in this kind of environment. And there is another study, so Milutin used all the data available for try to do a sort of temporal variability. So they compare the nematode assemblage from 2004 with the nematode assemblage from 2012. And what they see that the density was higher in 2012, and especially the composition of non-selective deposit feeders was 2 times enough. But the nematode diversity was lower, and they also observed a significant difference in genus at genus level. Especially Thalassomonistera was greater in 2012 respect to 2004, and Acantholimus and Theristus were lower. So they start to observe temporal variability. So it's a beginning. Of course, they need a lot of study to understand a possible temporal variability in this kind of environment, and they also put the hypothesis that it can be linked in some way with the primary production. So this is concerning the nodule. How I said before, we also have we also explore the possibility for polymetallic sulfide in the Atlantic Ocean. So this is the French claim area. And we did a cruise in 2014, the Bicos cruise, where we studied the TAC, the snack pit hydrothermal vent fields. So we have 3,500 meter water depth, more or less. So what we did was to study the meiofauna associated to the most important assemblages that were anemone, shrimps, and gastropods. This is for TAG. Sorry, for TAG was anemone and shrimps. For snack pit was gastropods and shrimps, and bathymodules. So just to explain a little bit how we sample in hydrothermal vent, because yesterday there was a little discussion. So what we do, normally we arrive with ROV or Sumara or whatever. We start to select our assemblages. So we select 3 areas, and we take the chemical measurement. So we use we have actually our instrument to take chemical physical data, and then we put Casimiri, that is our, for our idea, the surface that we sample. So we first pass an aspirator, so we suck the fauna, then we take the fauna directly, and then we pass the aspirator, and then we take photo during all this step, also for an idea for the animals that are in the surrounding. So, of course, we have a problem for sampling meiofauna in hard substrata. We are trying to do the best. So we are developing an aspirator with a sieve that can arrive at 20 micrometers. So we are testing. It will be FS. So we can it can be used by Victor and Nautil, and I think it can be in the next future used by other submarine. Because for the moment we have a very large filter size, because we cannot change the filter during the diving, and they immediately stop to work with the meiofauna, because of course the quantity of animals and types of things and organic matter in the filter completely block the system. So we are doing the best, but we start to have an idea, and effectively, as Daniel said, there is not a lot of species. We are really 10, 15 species. And another thing that we start to do is our colonization experiment. So, for example, in the snack pit, we used different kinds of substrata, organic and inorganic. So, inorganic are mainly slates, and for organic are woods and bones. And we select different sites from very inactive to very active, and we try to see the colonization processes of meiofauna, macrofauna in this kind of environment. Because, for example, when we study nematodes, we have to think that are animals without neuroplanktonic larvae, without very low mobility, and we are in a very ephemeral ecosystem in hydrothermal vents. So we are in an ecosystem that have a life that is linked with the vent emission. And when a new ecosystem, a new hydrothermal vent born, there are immediately macromeiofauna that can colonize this kind of environment. So we start to want to do a little bit more. So for the French claim area, we are still looking results. So I cannot show you nothing because we are still doing analysis. But I have an example from the Lucky Strike. So we are still in the mid-Atlantic reach, but we are 1,700 meter water depth, and we have something like 600 nautical miles, I think, from the claim area. So we study the colonization processes of meiofauna. So we show you a schematic representation of nematodes after 9 months and after 24 months, considering different sites from near the mission to very far away. So what we observe that after 9 months, the inorganic substrata are immediately colonized by a very abundant meiofauna community, particularly nematode, near the mission. And organic substrata are very high colonized far away from the vent emission. And if we look at the species composition of nematodes, we can see that the kind of substrata is the only factor that explains our differences, and not the environmental variables like temperature or gas emission and so on. After 2 years, there are some changes. We can see that organic substrata near the vent start to be more and more colonized, more than organic one. And if we look at the difference in composition and we try to understand who is the factor, are not the kind of substrata, but the vent emission. In general, what we see that after 9 months, we have a community that are full of juvenile, full of the female gravid, and there is immediately they immediately colonize different kinds of substrata. And after 2 years, what we can observe is a community more stable, without this very high abundance of juvenile and female. And we start to see depression of the environment, so depression of temperature, gas emission, and so on the species composition. So this is a little bit far away from the French claim area, but can be an example to meiofauna recovery, for example, in this kind of environment. And it's also a nice way to collect meiofauna, because when we take the substrata, we can have all the fauna associated. The last thing, I organized 2 years ago a Meio School. It was an international workshop for students and young researchers on meiofauna. So we spent 4 days with a lot of people here, with Daniel, with Andy, with Anna, with Reinhard, with Pedro, working on meiofauna. So it was quite successful with 120 participants from 26 countries. And we are doing a second edition next year, so it will be a summer school. This means 1 day more, 5 days, and a little bit of money more for pay student, young researchers to participate. So I hope that it will be an occasion for you also to be formed on meiofauna if you are interested. And there is the link. There is nothing in the site web today, but after Christmas you will have all the information available. And that's it. Thank you.
Any intermediate data between this 26 years period when you observe this track?
You mean temporal?
Temporal.
No, yeah.
Only we have data 26 years ago.
No, it was the work was made in this, the sample inside outside the track.
Inside the outside, but only inside.
Yeah.
But we compare with the.
No, we compare with the inside the track that was impacted 26 years ago. So it is there are no temporal data.
Yeah, maybe what we can mention in that framework, the cruises of Pedro, we revisited the site after 36 years. So we should have a follow-up on that specific track.
So, Daniel, how long time will it take that the noodles come back? 26 years and not and the noodles. How many years? So when they can come back, not the fauna, but the noodles itself, the manganese noodles. How many years will it take? So when you removed it, you could see that.
To have again.
How?
I think I am not a geologist, but I think several geologists here is millions of years.
So we talk about millions of years.
Another thing that yesterday Anne said is true, that we observe a difference in organic matter concentration inside at the site. Inside it was 30% higher, if I remember well, than outside. So there is a strong impact, and for nodule, we already know that our generation, next generation, will never know what will happen for nodules. But
Is any work done in the fauna which is in the nodules? Because here we are eliminating the hard substrate on a soft interface, so in water interface. The fauna associated within the nodule is gone.
It's gone.
So then there is extinction.
It's extinction.
Yes.
It's to do with the recolonization experiments. And this track, because everyone mentions it, and obviously it's a compacted track, there's no resedimentation on top of it, which is quite interesting. But most cases where mining will happen will be a mixture of compaction and redeposition. And what Volcano was saying this morning, that in areas of redeposition there was actually much faster recovery than on areas where it's left compacted on the deep sea floor. So do you think we have to be careful, if you like, with how we speak about mining and its effects, that we must make this distinction between compacted areas of seabed and those that may be redeposited, because the recovery times may be very different.
Yeah, of course. Very good. Very good.
And one other question. The LTC guidelines for myofauna, and to try and get consistency and standardization, say that myofauna should be retained on a 32 micron sieve. And yours is rather different. I don't know if you're going to move to a 32 microns.
Honestly, I work on 20.
Right,
Because I
a
prefer-
20?
Yeah.
Yeah.
Because for the cheaper tardigrade, I can see the differences when I use 20. But this is before me. There were no megafauna person at the time. I didn't follow the sampling, but now I am working.
Well, could you discuss at this workshop then what the lower limit of a myofaunal study should be?
Yeah.
Because at macrofaunal meeting, and from other meetings that we had, we reduced it from 300 microns to 250, and some of the contractors now are adopting the new standard. So it's quite important to discuss here what that lower limit should be, and to be able to advise the ISA about that.
I feel I can show you during the discussion. I tested sometimes to use 63, 40, 20. And for example, when I work on hydrothermal land, for all the little juveniles of Cephalophytosoma, you have to use 20. And it depends on what you want to do. But when you have a new species and you want to describe and you want to have everything from the juvenile to the adults, for the very little guy like tardigrade and the loricifer, I always found when I use 20. When I use the others, CV. So yeah, we have to discuss of these. Then it's more time consuming because it's more time to see. It's more material, more animals. But
okay, because then I suppose the conversation moves on to what's practical, what's possible. And while it's been suggested that you ignore all protozoans, which has had a reaction, then perhaps you have to set a larger sieve size, even though you know you're going to miss some fauna. But maybe for the purposes of monitoring mining and what happens and how quickly it recovers, it doesn't matter about moving to 20 microns.
I don't know. I always do both. So if you have to use 40 or 32 for the baseline study you have, and you have your little 20 for all the juvenile little animals.
For the exciting stuff.
Thank you very much.
Yeah, well,